You guys did really great with our Pythagorean theorem. A wonderful job. So don't forget to submit your Pythagorean theorem quiz. That's your assignment for that day. Today we're going through 45, 45, 90 triangles. So these are right triangles that have very specific formulas and patterns. So thinking about a square, let's start out with a square and I'll tell you what a 45, 45, 90 degree triangle is. So thinking about our angles here, these mean we have 90 degrees, right? So in your square you have all four of your angles are 90 degrees. This is kind of like our baseball problem that we went through in our quiz. If I cut a square directly down the diagonal, oh, that was a pretty good line right there. I'm bisecting the angles here. Remember our word bisecting, which means cutting in half, right? So I am bisecting my angles. Well, if I bisect a 90-degree angle, I have 45 degrees on both sides. So this is where they get the idea of a 45, 45, 90, right? So you have this little, you have this two 45, 45 degree triangles on either side. And what do we know about this kind of triangle? What we do know is that two of our sides are congruent, right? So that's what those lines are. Two of the sides are congruent. So they're equal to one another in length. So I'm going to call this value x. So whatever the value here is, I know that my other leg's value is equal. It's the same. What we don't know about this side, what we're going to do here is I'm going to prove what this side is using my x values here, okay? So if you want to think about this, if I have x squared plus x squared, so think about my Pythagorean theorem, right? A squared plus b squared equals c squared. I want to prove c, okay? I want to prove c. So I'm going to add these together because they're like terms. So I have 2x squared equals c squared. I'm going to solve for c, remember, by taking square root. And what happens there? Well, interesting things happen, right? Because I have the square root of 2 and the square root of x squared. Well, we know that the square root of anything squared is just itself. We proved that last time, right? So this is just x. My x comes out. But there's not a square root of 2. And remember, we want exact values. So I'm going to keep this as square root of 2. So look at what c equals. c equals x root 2. Now we're going to use this formula because this is true all the time, no matter what kind of 45, 45, 90 degree triangle you have. However, it only works with the 45, 45, 90, okay? So just keep that in mind. All right, so let's look at an example and actually apply numbers to it, values to it. So if I know that both of my legs are congruent, right? Both of my legs are congruent here. And I know that whatever this value is, and whatever these values are, then this, my hypotenuse, is that value times the x times the square root of 2. So let's write this down. I have a 5, right? So I know that this is also 5. So in this case, x equals 5. Well, if x equals 5, then what does x root 2 equal? X root 2. Well, I know that I can just plug in 5 here, so it's 5 root 2. So my AB, A to B, that's 5 because I know my legs are congruent. And A to C, my hypotenuse here, is 5 root 2 because x equals 5, and I just plug it in for that x value, 5 root 2. Let's do a different one. This one's a little bit tougher. My legs are here, right? And they're the same, so x and x. And this value, my hypotenuse, is x times the root 2, right? So this gets a little bit tricky because I want to solve for x. I want to know what x is. So I'm going to say, well, okay, I don't know what x equals. I don't know what x equals, but I do know that x times the square root of 2 equals 4, right? So this is where our knowledge of simplifying radicals comes in handy, because in order to solve for x here, I know that x is being multiplied to the square root of 2. So in order to solve, I have to divide by the square root of 2. Now this is where it kind of gets tricky, because we're going to have to rationalize our denominator, okay? So this is a little bit of a mini lesson. Rationalize the denominator. Math rules say that you cannot have a radical in the denominator, so I have to get rid of it. Well, I can't change a number without changing its value, so I have to change what it looks like without changing the actual value of the number. So anytime I can change a number without changing the value, I know that's confusing. The only way I can do that is to multiply it by 1. That's the only way that I can change a number without changing its value. So I want to get rid of this square root of 2 without changing the value. So I'm going to multiply it by a form of 1. So look at this, square root of 2 divided by square root of 2 is 1. But it'll help me get rid of this because it kind of does the same thing that we've done together. This is the square root of 2 squared. And what happens when you have the square root of something squared? Just like we did down here, right? It pops out. So what do I have on the top? I have 4 root 2, and then in the bottom it popped out, so I have a 2. Because these are both whole numbers, I can reduce, and I get 2 root 2. So this is my x value. I know that was a long drawn out, but I'm going to show you the pattern, right? If this is 4, right, my x value, we've proven, we've solved, that it's 2 root 2. X is 2 root 2. So I want you to see the pattern, okay? So I'm going to do a couple more over here. From get my marker. From that exact example, because you won't even have to do the math anymore, okay? That's the goal. I don't want you to have to do the math. Actually do the algebra. Well, you know, as a math teacher, I probably shouldn't say that, but I want it to be easy on you. So if I have 8 here, and x, so just like before, if it was 4, and my x values were 2 root 2 and 2 root 2, if this is 8, guess what? This is 4 root 2 and 4 root 2. Those are my leg lengths. I can prove it to you. If 8 equals x times the square root of 2, divide by root 2, divide by root 2, x equals 8 divided by root 2, rationalize, right? Do all that fancy legwork. So we have 8 root 2 over 2, because it pops out. 8 divided by 2 is 4 root 2. So I just proved that. Okay. What if we have a triangle that is 10? Has a hypotenuse of 10. So if my hypotenuse is 10, then my legs are going to be 5 root 2 and 5 root 2. See what I'm doing? I'm just dividing it by 2. That's the trick. That's the pattern. So let's see if this is 12, right? And that's my hypotenuse. If my hypotenuse is 12, then my legs are, you got it, 6 root 2 and 6 root 2. Just divide by 2. That's the pattern. We can do all the work, but if we notice the pattern, it's a lot faster for us, right? So let's move forward. Let's do one that's maybe not a decimal. I mean, not an even number. I made it super easy right there. What if it's 15? If it's 15, then I do the same thing. I just divide it by 2. What's 15 divided by 2? 7.5? Yeah. 7.5 root 2. That's it. Those are the leg lengths. Okay, so let's move on. We'll do one that's a little bit more difficult, like we can't get any more difficult than that. If I have 3 root 15, right? So if I know that this is x, right? This is x, and this is x times the square root of 2, I'm going to solve it the same way that I did here. I say 3 times the square root of 15 equals x times the square root of 2. Same thing up here. The way that I solved this was I divided by the square root of 2. Because they're both under the radical, I can divide them. So it's 3. Let's not do that. Let's do it. Let's just rationalize. How about that? I like that idea better. So we're going to rationalize. 3 root 15 divided by 2, and I have to multiply by a form of 1, right, to rationalize the denominator. So I'd try to get rid of that denominator. So I have 3 times the square root of 30 divided by 2, because it pops out, right? Alright, so my answer here, because no perfect squares, remember we talked about that? No perfect squares go into 30. I'm just going to leave it as square root of 30. So my answer is 3 root 30 over 2. That's your x value. Ugh, that is so ugly. And they're equal to each other. Don't forget that. Alright. So A to B is 3 root 30 divided by 2. And B to C is 3 root 30 divided by 2. We got that. Alright, let's look at 4. This is our last one, okay? I'm going to plug in. My legs are both x, right? And my hypotenuse is x times the square root of 2. So let's look at this. We're going to solve just like we did. 1/2 equals x times the square root of 2. How do I solve? I solve by dividing by the square root of 2, right? This is kind of gross, but it's the same as me saying 1/2 times like this. We can say that too, but that's a little bit more confusing, isn't it? So I'll keep it like that. So it's kind of like this. 1 over 2 root 2. That's the same thing. So I still have to rationalize, right? Because I can't have any denominators. I can't have any radicals in my denominator. So I'm going to do the same thing that I did. That's okay for this to be here. I need to get rid of that root 2. That's my ugly one. That's against the math rules. So I'm going to multiply across. So I have root 2 on the top. And on the bottom, that pops out. So I have 2 times 2, because that 2 popped out. So I have a root 2 over 4. That's your answer for x. So if 1/2 is my hypotenuse value, then my leg values are square root 2 over 4 and square root 2 over 4, right? Square root 2 over 4, square root 2 over 4 for BC. Okay, think about that. That makes sense, right? Because if my hypotenuse was 1/2, right? If my hypotenuse is 1/2, and all I do to find the other ones is cut my hypotenuse in half, which what's half of half is 1/4. What's half of a quarter, or it's half of a $1/2 is a quarter. So it's 1/4 square root of 2. Same thing, same thing. You can write it like this too. That works too. Either way. All right. We're going to review some more of these in class. We'll do an exit ticket together because I just want us to be really quick at the pattern, and we'll do some easy ones together. So I'll see you in class. We'll do notes first, asynchronous, and remember our attendance is going to be taken in class, okay, in the Zoom call. So you need to be in the Zoom call to be counted attended, okay? See you there.